Hello. In this video, we want to find the following limit. We have the limit as x approaches 2 of x squared plus x minus 6 all over x minus 2. Well, here's the thing. I already immediately know I can't just plug in this x to see what's happening here. The reason I know that is that I look at the denominator, plug in 2 minus 2, we have 0. We can never have 0 in the denominator. Now, something kind of weird happens as well, though. Plug in 2 in the numerator, 2 squared is 4, plus 2 is 6, 6 minus 6 is 0. So we get from this 0 over 0. Anytime you get 0 over 0, you should think to yourself that something weird is happening. And the reason that something weird is happening here is because this limit does in fact exist. It's just that the function f of x equaling x squared plus x minus 6 all over x minus 2 is undefined at x equals 2, but other things are happening. When you have a rational function and you have a common factor in both the numerator and denominator and they cancel, then that factor can produce a hole in the graph. But notice that when you have a hole in the graph, it can look something like this. This will look something like this, where you have, well, let's just do it this way. Something like that. Notice that going from the left, it's approaching this value. From the right, it's approaching this value. It'll never actually be that value, but it's getting really, 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 really close. So when this happens and you have a hole in the graph, you have the possibility of it actually being that value that you get from there. Now the question is how do you get this value? Well, this value comes from simplifying this and then plugging that into the function. So to do that, we have to simplify that fraction. But in order to simplify the fraction, the rational expression is probably a better word for it, we have to factor the numerator and factor the denominator. So factoring gives us the following. First of all, just rewrite your limit, and yes, you want your equal sign on to the left of the limit here. Now, factoring the limit, we want to factor the numerator and denominator. The denominator, though, can't be factored. There's only two terms, and neither of those have a common factor, so that's it. We can't do anything. But with the numerator, we have x squared plus x minus 6. That is a degree 2 trinomial, which can be factored. And when you have a degree 2 trinomial and there aren't any common factors, just begin with 2 sets of parentheses, usually. To get an x squared, you have an x and an x. And that's how you begin there. But now we have a minus sign there. And that minus sign tells me that they are opposite signs. We have a plus and a minus. If this was a plus sign, they would be the same sign, and then we would use whatever sign is here. Now ask yourself what multiplies to 6 and has a difference of 1. In other words, what are the factors of 6 that subtract to give you 1? Well, that's 3 and 2, or it can be 3 minus 2 or 2 minus 3, either one, but it's going to give you that's going to have a difference of 1. But between those two, let's say 3 minus 2, 2 minus 3, if you do this, which one of these gives you a positive 1? Well, the positive 1 is right here, so the 3 needs to be positive and the 2 needs to be negative. And there you go. Now notice that x minus 2 and x minus 2, those are both factors of both the numerator and denominator. And because they're factors, they cancel each other. The entire thing cancels. Be very careful about that. In other words, the x's here don't cancel, and these x's here don't cancel because they're not factors, they're terms of factors. Okay, so just be very careful with that. So really this limit is just asking me, what is the limit as x approaches 2 of x plus 3? That's it. That's all it is. So just plug in the 2 into the function. That's going to give us 2 plus 3, which is, of course, 5. Alrighty. So there you go. When you have something of 0 divided by 0, or something that looks like 0 divided by 0, often there is something that you can do to this to figure out what's going on. Alrighty, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.